Okay, in this video we're going to start looking at transformations by considering vertical translations, or vertical shifts. We're going to start from this parent function, which is described by the graph shown here, and we've also got this table of values which tells us the 5 key points marked with the red dots from that parent function. And we've called that parent function f of x. So the original function is called f, or f of x. And now we're going to do some things to it to change it. So the question says, given y is equal to f of x above, graph y is equal to f of x plus 3. What this means is that whereas in the original graph, the y coordinates were the output of the f function, because that's how it was defined, in this new one, the y coordinates are the output of the f function, but then with 3 added to them. So the original function is going to stay the same, but in this new graph, our y values are going to be 3 larger than they were in the original function. That's what this means. When we add a 3 on at the end here, it's saying our y values are 3 larger than our original function. So if this is our original function here, for the point -4, 0 is going to change to -4. The x value stays the same, but the y value is going to go from 0. Now we add 3 to it and get 3. For -2, we're going to add 3 to -4 because that was the y value above and get -1. For 0, the corresponding y value on the original function was 0. We add 3 and get 3. For 2, the y value was 2. We add 3 and get 5. And for 4, the y value was 0. We're going to add 3 and get 3. So that means that the new function is going to have these points. And look a bit like this. Oops, sorry, not a very good drawing, but you get the idea. So that would be our new function, or rather our new graph, y is equal to f of x plus 3. Whereas that one was moved up, now we're asked, given y is equal to f of x, the same function again, graph y is equal to f of x minus 1. So now all of the y values are going to have 1 subtracted from them. So instead of 0, we're going to have -1. Instead of -4, we have -5. Instead of 0, we have -1. Instead of 2, we have +1. And instead of 0, we have another -1. That means that these points, if we were to graph them over here, now look like this. And so the graph has the same shape, but is moved, sorry about the lines, you get the idea though. The graph has the same shape, but is moved down 1. So whereas before when we had f of x plus 3, the whole thing was moved up by 3, now when we had -1 at the end, the whole thing was moved down by 1. So vertical translations occur when you have something of the form y is equal to f of x plus c, and you'll see different letters here in different textbooks, but we're going to use C. It's the one used in your current textbook and is a common one as well, but it could be any letter really. When you add C at the end, it's going to move the graph up by C units, whatever that number is. We saw it as 3 in the first example, so it moved the graph up by 3 units. In this case, y is equal to x squared plus 5. You already know from studying quadratics that this is your standard parabola, but moved up by 5. And the same thing will apply for any function. Whereas if c is negative, the graph moves down. When we had -1 there, we moved the graph down 1. Also, you know from studying quadratics before that this, y is equal to x squared minus 3, would be a parabola moved down by 3, and the same thing will apply to any function. So if c is positive, the graph moves up by c units, and if c is negative, the graph moves down by the same number of units, or by c units rather. Next, we'll look at vertical stretches.